Hello, this is chapter 4, video number 4. We in the last video discussed how to calculate the equation of the line of best fit, and some of you guys might have seen this algebra and panicked a little bit. No worries, we're going to do it again. This is going to become familiar. Here's what we've got for this one. A history professor has calculated how many hours did somebody study, and then finally, what score did that class get on the exams. So we have a few kids. Ooh, kid that only studied 2 hours got a 60, whereas the kid that studied highest score was 90, it looks like. And that was for hours 5 and 6. So we have two variables here. We're going to go ahead and use hours to predict scores. So I'm going to recap how to do our line of best fit. So first off, let's go ahead and add a table. All right. And then we do need to type in these values. So we've got 3, 5, 2, 8, 2, 4, 4, 5, 6, 3. And finally, our scores that these students got. We had a 65, an 80, a 60, an 88, 66, 78, 85, 90, 90, and 71. And you are going to want to double check just to make sure that you're good. I believe in all of you. But before you actually calculate anything, just double check to make sure those values are matching up. All right, so looking at this data, it is pretty clear that this is a positive relationship. I mean, I guess we could zoom in a little bit to see that. I'm going to go ahead and change my y-axis to be out of 100. All right, and for my x-axis, we'll just go from -2. You don't have to do this. I'm just doing it for a visual. All right, so looking at this, it's kind of clear that as you go up, it seems to be going up as well. It does seem to be linear, strong, positive. All right, let's go ahead and calculate that line of best fit. So we are trying to predict y sub 1. Y sub 1 is approximately mx sub 1 plus b. All right, our R value is 0.846, so that's telling me it's a pretty strong relationship. All right, and looking at this, our slope is 5.04, and our y-intercept is 56.11. All right, so I'm going to go ahead and type that in just so we have that on record, and then we're going to go ahead and use that here in just a minute. All right, so first off, our slope was 5.04. I'm going to go ahead and round to 2 decimal places. And our y-intercept is 56.11. All right, and we are done with Desmos. I'll go ahead and make this just a little bit bigger. All right, so what can we do with this? I'm going to go ahead and substitute in up here. We have 5.04, and finally this was 56.11. So what the heck does this equation mean? What does this slope mean? What does this y-intercept mean? Well, that is the purpose of this video. We're going to talk about how do we interpret these values. All right, so I really don't have any preference, but I'm going to go ahead and just start with my y-intercepts. So the y-intercept here, the y-intercept is 56.11. And you guys might recall that a y-intercept is a point. This is the point 0, 56.11. All right, the point 0, 56.11. So what does this mean in the context of this problem? Well, this would be the predicted score if, hey, x is our hours. So this would be 0 hours. And then we are predicting this score. So this is what this context means. So a student that studied for 0 hours would be predicted to have a test score of 56.11. Not very good, but it seems to make sense in this problem. And if we were to look back at our graph here, here is where that is. 0 hours studied, we are predicted to have a score of 56.114. Now let's talk about slope. Slope, all of you guys probably from middle school or high school, as soon as you hear slope, you think rise over run. But let's go ahead and talk about it in terms of a statistics perspective. So in this problem, our slope is 5.04. All right, our slope is 5.04. Now let's talk about our x value is hours. So here's what this means. If we have a slope of 5 And some of you guys might be thinking back to algebra, up 5 over 1, up 5 over 1. Here's what it means here. For every additional hour studied, the exam score is predicted to increase by 5.04%. All right, so our slope was right here. And if I plugged in 1 hour, our score would go up by 5%. If I plugged in 2 hours, our score would go up by 10% because I got 2 extra hours. Plugged in 3, I would go up by 15%. So that is what we are expected to go up every single additional hour. All right, so quick recap. Y-intercept stands for our starting value. If we have 0 hours studied, that would be our predicted score. And then our slope tells us how far are we going up each time. With every additional hour, you're expected to have about a 5% increase. Now, does everybody fall on this line? No, but this is just a general trend. This person, they studied the most, but they didn't have the highest score. That's okay. Maybe they studied because they were weaker in the material. Who knows? Remember, this is just a predicted score. This is our predicted trend. Most likely will happen, but it's not guaranteed.